so we're going to continue on in our packet today. Then our goal is to get to some cool graphs by the end of the day. I think we can make it. I think we can handle it. Okay? So, algebraically wise, if I said we've got r equals 3 sine of theta, and I want to convert that into rectangular form. It's in polar form. I want to convert it into rectangular form. Well, I got a couple of algebraic options that I can go with. Okay? I could square both sides. Bless you. Right? That's doable, right? Okay? If I square both sides, then I get r squared on the left, and I get 9 sine squared of theta on the right. Okay? R times itself is r squared. 3 sine quantity squared would get me 9 sine squared. Now with the tools that I have in my toolbox, that doesn't help me any, because I need an r sine theta, or I need an r cosine theta in order to switch it back from, or into x or y. Okay? That's not going to help. X squared plus y squared, so I'd have, the best I could do here would be x squared plus y squared equals 9 times the sine squared of theta. Not going to do me any good. Okay? So that's not going to do it. Can't do that. Okay? Another one I could do, another algebraic method that I could do, is I could divide both sides by the sine of theta. Maybe get r and the sine of theta all on the same side. Well, that would give me r divided by the sine of theta equals 3. But that doesn't help me either, because I need r times the sine of theta, not r divided by the sine of theta. So that's not going to help me either. Okay? So both of these didn't work out. Okay? But what I can do is I can multiply both sides by the same thing. And in this case, I'm going to multiply both sides by r. And if I do that, then I would get r equals 3 sine of theta. If I multiply both sides by r, on the right side, or excuse me, left side, I get r squared. On the right side, I get 3r times the sine of theta. Now that helps me out, because r times the sine of theta here, that's y. Right? And r squared here, that's x squared plus y squared. So what I've done is I've completely gotten rid of r and theta. In all of those other ones, in the blue one, I still had a theta. In the green one, I still had an r and a sine of theta. Okay? So I didn't get rid of anything in that one. So over here, I've gotten rid of everything, and then just to make it look pretty, we're going to bring that 3y onto the same side, and my equation, this equation, is the equation of a circle. It has a center at 0, 1.5, and it's got a radius of 1.5. Okay? Now, you guys haven't learned conic sections yet, okay? But I did that by completing the square. Okay, so what I did here is I said, actually we'll do it in black, I said, well, x squared is really x minus 0 quantity squared, and y squared minus 3y is really y minus 3/2 quantity squared. But then I had to add 9/4 to both sides to keep it balanced. And that is the equation of a circle with center at 0, 3/2, and it's got a radius of 3/2. Okay? So on my graph, we said it was r equals 3 times the sine of, of course it will, times the sine of theta gets me there. Okay, okay, so let's graph polar equations now. Okay? So we're going to graph some polar equations. So what I would like you to do is, I think you can handle these two. I want you to graph those two polar equations and also convert them into rectangular. Okay? Go for it. First one, what is the graph? What is this graph? R equals 2. Polar-wise. Dylan, what do you got?
It will be a circle at the second line.
Okay, so it's centered at the pole.
Right.
Okay, with
a radius of 2.
Radius of 2. So I would start out here, right? And I would work counterclockwise around that 2 ring. Yes? Okay, so there's that one. If I convert this one, r equals 2, if I convert that, I would square both sides, which would give me r squared equals 4. And r squared then is x squared plus y squared. That would equal 4, which is a circle centered at the origin with radius of 2. When it's just a number, it's fine to keep that number over there. But if it were for y or for x, yeah, then bring it over. Okay? Yeah, but if it's just a number, it can stay over there. Okay? Good question. Okay? What about number 2? R equals negative 3 now. Lukey? So I go left 3, right? Okay, so my starting point is right there this time, right? Because that's 0 degrees, but a negative r value. Okay, and then what do? It's a circle, okay? But it's coming around this way, right? Okay, so it still gives me a circle. But if I were to trace those values, I wouldn't be, so like let's say I wanted to know the value of this function at 90 degrees, right? So you would think that it would be right there, correct? But really, where am I at 90 degrees? I'm way down at the bottom of the circle. So it really is, so this would be negative 3, 90 degrees would be the point that I would be at. Okay? So it still makes me a circle, but I've got to think on the opposite side of the circle because the r value is negative. If I wanted to convert this, I would square both sides. And that would give me r squared equals 9. So that is x squared plus y squared equals 9. Okay? center at the origin, radius of 3. Okay. All good. Okay. Let's try 2 more. Try graphing those 2 and converting them into rectangular form. Theta equals 120 degrees. I would find where theta is 120 degrees, so that's right there on that ray. And then what I would do is I would take, come on now, come with me. Come with me now, there we go. Okay, I would take this and I would adjust it to there. Right? Okay, so that's my line, my picture, if you will. Converting it, remember we learned the tool yesterday that the slope of our line is the tangent of the theta, and the tangent of theta here is going to be at 120. It's going to be the square root of 3 over 2 divided by negative 1/2, which is negative square root of 3. So this line becomes y equals negative square root of 3 times x, because it goes through the pole. So that's plus 0 then. Okay. Negative 120. So my angle for negative 120 is right there. So there's my line. My slope is going to be the tangent of negative 120 degrees, which is going to be negative 120 is going to be negative square root of 3 over 2 divided by negative 1/2, which is going to just be positive square root of 3. So my line, because it goes through the pole, is that. Let's see. Okay? Fantastic. Now, let's get into some funkier graphs. Okay? Now, if you turn the page, I think it's the page that says note sheet at the top on it. It looks like this. These graphs are right on there for you, so you don't have to. So that's what page we should be on in our purple packet now. Okay? R sine of theta equals 2. Okay? Let's go about this a little different way. Let's, instead of graphing it first and then converting it, let's convert it first and put that then on our graph. Okay? So r sine of theta. What's r sine of theta? That's y, right? So this really is y equals 2. What kind of a graph is y equals 2? It's a horizontal line, 2 up off of that x-axis, right? Okay. Polarity-wise, it would look like I just wanted to move it. Well, come on now. There we go. Now it would look like that. It's a line that has to go through the point y equals 2. Well, the point y equals 2 is right here. So a horizontal line that goes through that point is that line. our cosine of theta equals -3. Our cosine of theta is what? X. So this really is x equals -3. Yes? What kind of a line is that? Vertical line. It's got to go through -3. So the -3, 1, 2, 3. Well, nope, that's 2. That one. So it's got to go through that point. Get it. Get it. Hit it. Boom. Okay. So there's that one. Handle so far? Now let's get funky. Okay? We're going to baby step it first. Okay? I'm going to make you think all the way back to when we first started trig. When we started graphing trigonometric functions. Okay? So if I wanted to graph 4 cosine of theta, right? Okay? The 4 tells me that I have an amplitude of, I go all the way up to 4 and I go all the way down to -4 because there's no extra stuff at the end. That tells me that my middle is at 0. And I go up 4, down 4 from my middle. Yes? Okay? Now we said that cosine functions way back then were periodic, which means they repeat themselves every 2 pi. But today I'm going to go with degrees. Normally, we would go pi over 2, pi, 3 pi over 2, and 2 pi. Okay? Now, my question is, remembering back, does cosine start in the middle, or does it start on top? Starts on the top, right? And then it comes to the, so it starts up here, then it comes to the middle, then it goes to the bottom, then it comes back to the middle, and then it finally finishes off up on top, right? Okay? So that graph looks like that. That's my cosine curve for cosine theta. Bringing back some old memories. Okay? We're going to polarly graph that exact function. That is my rectangular function. Okay? Actually, I shouldn't say that's my rectangular function. That's my r's are here, thetas are here function. Okay? So now, let's graph that thing. So when theta is 0 degrees, what is the value of that function? 4, right there, right? Yes? On the polar graph, here's my 0 degree ray. My value is 4, so I need to go out 1, 2, 3, 4 to get there. Yes? Okay. What's my next key point? Or easy point to find off of this left graph?
The radius is 0 at 90 degrees.
The radius is 0. Oops, no, I didn't want to go there. Tap the brakes. I wanted to skip a line. The radius is 0 at 90 degrees. So at 90 degrees, which is straight up and down, my radius is 0. So I'm right at the pole. Right? Okay. What's my next easiest one to find? Right?
180, it's -4.
At 180 degrees, it's -4. So here's 180 degrees, right? Where would the radius be of -4? Along that 180 degree ray. Where is it? Which way do I have to go? I got a radius of -4. If I had a positive, I would go out to the left. But because it's negative, I have to go to the right. So it actually ends up being that original dot that we put on there. Right? Okay. Next easiest one. At 270 degrees, we're back to 0. Right? So at 270 degrees, I'm at 0. Well, that's the pole again. So far I've found 4 points, but it really only polarly graphed me 2 points. Okay? What's another one? Right? Which is my original black dot. I should end up, because it's cyclical, I should end up back at the exact same point. Okay? Sweet. Awesome. Love it. Ecstatic. Now, but let's fill in some more points. So, what would halfway between 90 and 0 be? 45? Okay. So, what is the value of my function at 45 degrees? Not 2. Not 2.5. Can I just, what? Not square root 2 over 2. 2 square roots of 2. Okay? Because the sine, or the cosine here, at 45 degrees is 2 square root of 2 over 2, right? But then that has to be multiplied by 4. So this is really 2 square roots of 2, which is like 2.83. Right? Okay? So at 45 degrees now, here's my 45 degree ray, I have to go out 2.83. Yes? Okay. What's halfway between 90 and 180? 135? What's the value of my function at 135 degrees? That's the cosine, right? The cosine of 135 degrees is negative root 2 over 2, right? Times 4 would be negative 2 times the square root of 2. So that's negative 2.83, right? Let me put those on here. So that's up here, and this one would be down here. Okay? So here is 135 degrees, but I need to go in the negative direction because I got a negative R value. So instead of going up and to the left, I got to go down and to the right, 2.83. 2.83. Right? Halfway between 180 and 270. 225, right? That should be negative 2.83 because it's the same as the one we just found. So at 225 here, negative 2.83 is actually that first purple point. Halfway here is 315 degrees. Those are the same. So at 315, I'm right there. Okay? So my graph here ends up looking like I'm going to start at 0. So I start there, and then I went to 2.83, and then I went to 0, and then I went to negative 2.83, and then I went to negative 4, which is back to there, and then I just went around a second time. Okay? Kind of a funky looking circle, but it should be a circle. Okay? With a radius of, what's the radius of that circle? No. Radius is 2 because the center is shifted over. Okay? Let's graph that one on so we said, what was it? It was 4 cosine of theta. 4 trig cosine of theta. And there it is. Okay. Now our minds are going to be blown. Okay? So here's our function. 1 minus 3 cosine of theta. Now you might have or remember this as negative 3 cosine of theta plus 1. Right? Same thing. Where's the middle of that function? The middle line is where? Positive 1. Amplitude of that function? 3. So that means from the middle I go up 3. So I'd go all the way up to 4. And I'd go down 3. So I'd go down all the way to negative 2, right? Okay. 90, 180, 270, 360. Right? Cosine normally starts high or in the middle? Normally it starts high. Does that negative out in front do anything to it? Starts it at the bottom then, right? Okay, so I'm going to start there. Then I go to the middle. Then I would go up high. Then back to the middle. And lastly, ending down low. Right? Okay? So, let's graph our points. Now, when we graph points, then we're going to kind of fill in points every 3 points. We'll fill it in. Okay? All right? So, let's start at 0, which had better also be 360. So, that's going to be our ending point also. Okay? What's the value of my function at 0 and 360? Negative 2. Put that point on a polar graph. Here is 0 and 360, and our value of negative 2 is right there. Right? Okay. Next easiest point. Even easier than that. 90, right? Okay. So we could go to 90 degrees. And what's the value of our function at 90 degrees? 1. Yep. It's 1. Okay. In between there would be what? 45, right? So what's the value of my function at 45 degrees? -1 minus 3 times the cosine of 45 degrees. Somebody on a calculator.
How come the -2 is going in the opposite direction like the last one?
It did go the opposite direction. 0 is over here by my hand. So we went towards the 180. Okay? Right? Value of my function here? Anybody? 1 minus 3 times the cosine of 45 degrees on a calculator? -1.12. So here's 45 degrees, right? So a value of -1.12 would be right in there. Yes? So my function, then at 90 degrees, it's 1. So now here's why I said we're going to do it every 3 points. Because we need to follow along where that's going. I started at the black, then I went to the purple, and now I'm going to the red. Okay? Next one would be, next easiest one would be 180 degrees, right? What's the value of my function at 180 degrees? 4? So at 180 degrees, 1, 2, 3, and 4, I go through there. Well, let's see what it does halfway between there. Halfway between there was, we said, 135 degrees. Somebody using a calculator, 1 minus 3 cosines of 135 degrees. 3.12. So on this 135 degree ray, I need to go out 3.12 radians, or radiuses. 1, 2, 3.12 goes through there. So from my red point, I went to my orange point, and I went to my green point. Yes? Okay, doing good so far. Next easiest one, probably going to be 270, right? What's the value of my function at 270? 1. So at 270, I'm there. Okay, let's go halfway. I forgot to put these in there. So there's purple, and then there's that one. So halfway between 180 and 270 is 225. And that one is going to be the same as 135, correct? So that should be 3.12. So 225 degrees is down here. 1, 2, 3.12 puts me there. So I go from green to weird orange to blue. Right? I know I have to end at 360. We calculated that one up top. That's -2. That's the black dot on my graph. So halfway between those two would be 315 degrees. And these two are the same. So that should be -1.12. That's the wonderful thing about trigonometric functions, is they have reflexivity. So at 315 degrees, which is right there, I go -1, so I go back through the pole, -1.12, and so then it finishes off here with that. That's awesome. I love it. On a calculator, on a calculator, come on now, on a calculator it looks like 1 minus 3 cosine of theta. Boom! Boom goes the dynamite. Now the cool thing, the downfall, I should say, with technology is it's so fast. Okay? On the old TI-81s and TI-82s and TI-83s, you could see this graph being built, just how we did it. Because you could slow the T-step down and it would slowly build that double helix or whatever you want to call it. Okay? Alright? We'll pick up on this tomorrow. We'll do those last two graphs tomorrow, and then we'll be ready for our test on Friday.